So welcome to part 3 of vector algebra, and in this video we're going to be seeing how to find the magnitude of a given vector. So we're going to start off with a simple example from the previous video, and the first thing of course is drawing our Cartesian plane. So there's x, the negative x, y, negative y, z and negative z axis. Okay, so now I'm going to consider a vector from the previous video, namely 2 I cap. So just a small recollection, this I cap part is basically the part that contains the data of the direction. So the I cap specifies the vector is along the x axis, the positive x axis, and this 2 is the scalar part. It basically tells you the length. So whenever you have a simple vector like this with just one component, we can very easily plot or draw the vector. So this 2 I cap will be a vector along the positive x axis whose length happens to be 2 square units. Correct? But if I were to give you a little bit more complex vector, say for example 7 I cap plus 2 j cap plus 9 k cap, and let's assume this is somewhere over here at point P. So now if I were to join this with the origin, this becomes the vector OP, and now I'm asking you to find the magnitude or the length of vector OP. Now you can't do the same thing that you did for this vector. You have to apply some rule or something new to find the magnitude of this vector. So we're going to focus on how to find the magnitude of any given complex vector such as this one. Okay, so I'm going to start off with a very simple example of just 2 dimensions. We're not going to consider the z axis at all. We're just going to consider the x and the y axis, the positive and the negative ones. So now I'm going to plot a very simple vector. Let's say I move 1 unit along the x axis, okay? So this is 1 unit along the x axis, and I move 2 units along the y axis. So this is 1, this is 2, and this point over here is represented by 1, 2, or since we know the notation of vectors, we can call it I cap plus 2 j cap. So now what I'm going to do, I'm going to connect this and the origin. If this were point P and the origin were to be point O, we're going to try and calculate the magnitude of line OP, or the length of the vector OP. Okay, so now we're going to go to a little bit of basic math that we would have learned in our high school. So let's assume a right triangle. Let's call this A, B and C, and let the angle B be the 90-degree angle. Now there are a few rules about a right triangle that most of us know, but even if you don't, I'm going to teach you those rules over here. So now if the length of this side AB happens to be A, and the length of side BC happens to be B, and length of the side AC is C. So now the longest side of any right triangle is known as the hypotenuse. So over here the hypotenuse happens to be AC, and the length of the hypotenuse is C. So now using Pythagoras Theorem, we know a simple derivation which says A square plus B square equals C square. So what does this mean? The sum of the individual squares of the 2 non-hypotenuse sides of a right triangle is equal to the sum of the hypotenuse length square. So A square plus B square equals C square in a right triangle, correct? So now if you were to consider this vector over here OP, and let's say I were to extend by dotted lines over here and here, and if you were to consider just this part, let me name this point to be Q. So now if you see OPQ forms a right triangle with a right angle at this point, correct? It's pretty obvious. So now if you see, this happens to be the hypotenuse because the side opposite to the 90-degree is the hypotenuse. So over here this is the 90-degree, and the side opposite to this 90-degree is this line. So this is the hypotenuse. So now if I consider this length to be A, this length to be B, I know A square plus B square is going to give me C square, where C is the length of the vector or the magnitude of the vector. So now we know A is 1 unit because we're traversing only 1 unit along the x-axis. So A will be 1. And now since we're traveling 2 units along the y-axis, B would be 2. So A is 1 and B is 2. So now if I were to apply this Pythagoras theorem that I told you guys over here, 1 square plus 2 square must be C square, where C is the magnitude or the length of the vector OP. So 1 square is 1, 2 square is 4 is equal to C square. So you know C from this happens to be root 5. So the length of the vector OP happens to be root 5 square units. That is, the length of this vector OP or this line OP is root 5 square units, which happens to be its magnitude. Okay, so now that we've learned on how to calculate the magnitude of a vector in 2 dimensions, we're going to apply the same to a vector in 3 dimensions. That is, including the positive and negative z-axis. So let me consider an arbitrary point P, and let me denote the origin to be O. If I connect these points, this vector happens to be OP bar. And let me denote this vector OP bar to be 5i cap plus 4j cap plus 7k cap. So what did we do last time? We did not have the k cap part, correct? We just had the I cap and the j cap parts. So all that we essentially did using Pythagoras theorem to calculate the magnitude was we did the magnitude of the vector or OP. The magnitude is represented by these 2 lines. It's called the modulus. These 2 lines are called modulus. So when I say mod OP bar, this mod means magnitude. So mod of anything will give you the magnitude of that thing. So when I say mod OP bar, it gives you the magnitude of OP vector. So all that we did to calculate the magnitude when we did not have the k cap part was under root 5 square plus 4 square, correct? We did under root 5 square plus 4 square using Pythagoras theorem, because we said a square plus b square equals c square is equal to under root a square plus b square. So we're just going to extend that. Now since we have a third vector or the third component of this vector, all that we'll have to include in the magnitude equation, OP bar is equal to under root. Of course the first component comes as it is 5 square plus 4 square. We just have to include the k cap part 2 plus 7 square, and that is it. It's as simple as that. Now once we finish this, we'll get the magnitude of the vector, which in this case will be OP bar mod again represents the magnitude, is equal to under root 5 square is 25, 4 square is 16, 7 square is 49. So now this happens to be under root 90. So now under root 90 is the length of this line or the length of this vector or the magnitude of this vector. So if this is still kind of confusing for you, all that we're doing over here, we're applying Pythagoras theorem in 3 dimensions. But I didn't want to teach you that way because it will be more confusing. The visualization part would be quite difficult because you wouldn't have to consider a triangle just in 2D plane, but you'll have to consider in 3 dimensions, a line coming towards you, and then it will be difficult for you to visualize the 90-degree angle and the hypotenuse. So in general, whenever you have a vector with n number of components along n number of axes, the magnitude is under root each component squared. So let me generalize this concept. So whenever you have a vector, let's say ai cap plus bj cap plus ck cap, let me call this to be, let's say d bar. D bar is this vector. Now what is the magnitude of vector d? That is mod d bar will just be under root a square plus b square plus c square. So that is it for part 3 on how to calculate the magnitude of any given vector. If you liked the video and you found it useful, do like and subscribe. Thank you.